following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmail@ybcc.edu and I'll respond as soon as I can. All right, so today we're going to take a look at section 7.5, which is simplifying complex fractions. So let's start out by looking at the difference between a complex fraction and a simple fraction. A simple fraction, examples would be 2/3, x plus y over z plus 4, 2.5 over x minus 3. With a simple fraction, there's just the one fraction, and there's a numerator and a denominator. Now, a complex fraction, there's going to be at least two fractions. So you've got the main fraction, but then you might also have a fraction in the numerator and or the denominator of the bigger main fraction. So this is a complex fraction, or x over y plus z over w over 7. That's a complex fraction because there's more than one fraction within the bigger fraction. What we're going to be looking at today is taking a complex fraction and simplifying it down to a simple fraction, and then if it can be reduced further, we'll do so. The first ones we're going to look at are the less complicated complex fractions. I know that's kind of a contradiction, but for instance, let's say we've got 3/5 divided by 2/7. So we've got a fraction, a single fraction in the numerator and a single fraction in the denominator of the bigger complex fraction. We could rewrite this as 3/5 divided by 2/7. But we could write that as 3/5 times the reciprocal of 2/7, which would be 7 over 2. And now, multiplying the fraction straight across, we get 21 over 10, which does not reduce. Let's take a look at another example. Let's say we've got n divided by 8 all over 1 divided by n squared. We have a single fraction divided by a single fraction. We can rewrite it as n divided by 8, the whole thing divided by 1 over n squared, which is equal to n divided by 8 times the reciprocal of 1 over n squared, which is n squared over 1. And then multiplying straight across, we get n cubed over 8. So when we have a single fraction divided by a single fraction in the form of a complex fraction, we can use this process. Now, what if things get more complicated? For instance, in this case, we have 2/3 minus 5/2 all over 2/3 minus 3/2. One way we could go about it would be to take the numerator and those two fractions and get a common denominator and subtract them and get the results and break it down and get it down to a single fraction on top and do the same thing on the bottom and then do what we just did. But there's an easier way, a quicker way to accomplish the same thing. What we're going to do, we're going to look at all of the little denominators. So the 3, the 2, the 3, the 2. We're going to find the least common denominator, which would be 6. Okay, so now what we're going to do is we're going to multiply the entire complex fraction by 1. But we're going to write that 1 as the LCD over the LCD. So 6 over 6. And the reason I wrote 6 over 1, 6 over 1 was so that you would see that this 6 on top lines up here, this 6 on top of the denominator lines up there. Okay, now I'm going to recopy that whole mess without all the circles and arrows and things. So what I've got is this. I've got 2/3 minus 5/2 over 2/3 minus 3/2 times 6/1 divided by 6/1. Okay, now I'm going to distribute. 6 times 2/3 would be 12/3 or 4. 6 times minus 5/2 would be minus 30/2 or minus 15. In the denominator, 6 times 2/3 is 12/3 or 4, minus 6 times 3/2, which would be minus 18/2 or minus 9. Okay, and then this would be equal to what? Negative 11 over negative 5, which could be simplified down to 11/5. So we changed it to a simple fraction and reduced it down. Well, in this case, we just got rid of the double negative signs. All right. Next question. Let's see here. We've got 2 over x minus 1/3 divided by 2 over 3 plus x over 5. So we're going to multiply both sides by the least common denominator over the least common denominator. Let's see, my denominators are x, 3, 3, and 5. So my least common denominator is 15x. 3 times 5 times x. So I'm going to multiply the top by 15x and the bottom by 15x. Okay. Let's see here. If we take 2 over x times 15x over 1, we get 30. And then minus, we've got 1/3 times 15x over 1. 15 over 3 reduces to 5, so we've got minus 5x. In the denominator, if we take 2/3 times 15x over 1, we get 10x. Okay, let's see, 30, yep, 10x. And then if we take x over 5 times 15x over 1, we get 3x squared. Okay, so far so good. Now, I can factor a 5 out of the numerator, and I can factor an x out of the denominator. But when I do that, it doesn't give me any common factors in the numerator and denominator to reduce. So we'll just go back to this as our final answer. Okay. Let's see here. We have 10 over n minus n over 4 divided by 8 over n. The least common denominator of n, 4, and n would be 4n. So I'm going to multiply the numerator and the denominator by 4n. Distributing, 10 over n times 4n over 1 would be 40, minus n over 4 times 4n over 1 would be n squared. In the denominator, 8 over n times 4n over 1 would be 32. I can't do anything in the numerator to simplify it or to factor it, so that's going to be my final answer. All right, Let's take a look at another example. 3/5 minus 2 over 2/5 minus 2. Well, we have some implied denominators of 1s there. The LCD of 5, 1, 5, and 1 would be 5. Okay, so we're going to multiply 3/5 times 5, which is going to be 3, minus 2 times 5, which is going to be 10, over 2/5 times 5, which is going to be 2, minus 2 times 5, I guess there's an implied one there, which is 10. 3 minus 10 is -7. 2 minus 10 is -8. And that could be simplified further down to 7/8. All righty. Let's see here. We've got 3/4 plus 1 over y divided by 5/6 minus 1 over y. So the least common denominator of 4, y, 6, and y would be 12y. So I'm going to multiply the top by 12y and the bottom by 12y. Distributing 3/4 times 12y. Let's see, 12 over 4 is 3, so we get 9y plus 1 over y times 12y over 1, which is 12. Come on, eraser. Work. There we go. All right. In the denominator, 5/6 times 12y over 1, which is 10y, minus 1 over y times 12y over 1, which is 12. Okay. Well, let's see. I can factor a 3 out of the numerator and have 3y plus 4. I could factor a 2 out of the denominator and have 5y minus 6. But again, that doesn't get me anywhere. So my final answer is just going to be 9y plus 12 over 10y minus 12. Okay, let's see here. 1 divided by x minus 1 all over 1 minus 1 over x minus 1. Write that a little. Come on. Here we go, finally. Just want to make this a little nicer and we'll put it right there in the middle, like that. Okay. So what are my denominators? In the numerator of the complex fraction, I've got an x minus 1. In the denominator, that 1 that's over on the left has an implied denominator of a 1. And then the second term has a denominator of x minus 1. So we've got x minus 1, 1, and x minus 1. So the least common denominator is going to be x minus 1. So I'm going to multiply the numerator and the denominator of the complex fraction by x minus 1. Okay. On top, 1 over x minus 1 times x minus 1 over 1 reduces down to just 1. In the bottom, 1 times x minus 1 over 1 is x minus 1. Okay. And then minus 1 over x minus 1 times x minus 1 over 1 reduces down to 1. So I get 1 over x minus 2. All righty. Let's see here. Let's do how about this one? 8x minus 64 over y divided by x squared minus 64 over y squared. Well, we could go back to the very first problems we looked at because this is a single fraction divided by a single fraction. So I could rewrite this as 8x minus 64 over y divided by x squared minus 64 over y squared. And then I could rewrite that as 8x minus 64 over y times the reciprocal y squared over x squared minus 64. Okay, so now I'm multiplying two fractions. I'm going to factor an 8 out of the top and factor the difference of two squares on the bottom right-hand side. So now the x minus 8's reduce down to 1 over 1. The y squared over y reduces to y over 1. And in the numerator, I have 8 times 1 times y, or 8y. In the denominator, I have 1 times x plus 8 times 1, which is x plus 8. And so we get that. Okay. I'm actually going to go back and do that problem the other way. You can do all of them that second way, but let's look at this one, doing it the other way. You might decide you want to do them all this second way, but again, it's more work when you don't have to do it that way, and you still do it that way. Okay, so here the LCD would be what? Y squared. So, we're going to take this. That's going to be what? Y times 8x minus 64. And at the bottom, that's going to be x squared minus 64. Let's see here. Can I do anything with that? I've got y times what? Take out an 8 and have x minus 8. Okay, I just took the 8 out of here and moved it out front. And then x plus 8, x minus 8, those reduce out 8y over x plus 8. That perhaps was a little harder to follow what happened right there, but the results are the same. Okay, here we have 1 minus p plus 2 over p, all divided by 6 over p squared plus 1 over p minus 1. So we have 3 terms in the numerator and 3 terms in the denominator. So the LCD is going to be, well, let's see, I've got an implied 1, an implied 1, and a p squared, p, and an implied 1. So it would just be p squared. Okay? So I'm going to multiply by p squared over 1 on top, p squared over 1 on the bottom. Okay? So 1 times p squared over 1 is just going to be p squared, and then minus p times p squared over 1, which would be p cubed, and then plus 2 over p times p squared over 1, which would be minus 2p. Then in the denominator, 6 over p squared times p squared over 1 would just be 6 plus 1 over p times p squared over 1, which would just be p minus 1 times p squared over 1, which would be p squared. Okay, let's see if we can deal with that mess and make it into something a little nicer. I'm going to take the numerator of that fraction and put it in descending powers. So negative p cubed plus p squared plus 2p. in the denominator, negative p squared plus p plus 6. Okay. I'm going to take that and recopy it on the next page because I need some more room. So negative p cubed plus p squared plus 2p, okay, over negative p squared plus p plus 6, plus p plus 6. Okay. I'm going to factor a negative p out of the numerator, which is going to give me p squared minus p minus 2. I'm going to factor a negative out of the denominator, which is going to give me p squared minus p minus 6. Okay, let's see, just double checking that. Now I'm going to factor the numerator further and have negative p times p minus 2p plus 1. And the denominator negative times p minus 3p plus 2. And after doing all of that, the only thing that I can get rid of is the double negative. So negative p divided by p would be a positive. So I end up with that. So after all of that, the only thing I was able to reduce out was the negative 1 on top and the negative 1 on the bottom. But I had to figure it out. Okay. Let's see here. How about let's do this one. 2 minus 2 over x plus 1 all over 2 plus 2 over x plus 1. Yeah. And see if I can write it a little more legibly. 2 minus 2 over x plus 1. So my implied denominator here and here is a 1 and a 1. So basically my least common denominator is just x plus 1. So I'm going to multiply by x plus 1 over x plus 1 and distribute. 2 times x plus 1 over 1 would be what? 2x plus 2. So 2x plus 2. And then minus 2 times x plus 1 times x plus 1 over 1. The x plus 1s would reduce out, so we'd have minus 2. In the denominator, 2 times x plus 1 over 1 would be 2x plus 2, distributing. Okay, and then plus 2 over x plus 1 plus, or times x plus 1 over 1, which is 2. So in the numerator, the 2's would cross out and I'd have 2x. In the denominator, the 2 plus 2 would be 4. Okay. I could factor a 2 out of the denominator and then reduce it down to just x over x plus 2. And there you have it. So that's it for today. Section 7.5, Simplifying Complex Fractions. I'll be back this afternoon at 1:15 with an office hour. Otherwise, have a great weekend, and I'll be here on Monday.